Hello, hello, hello. Welcome to another dev stream. Yeah, let's get started. Going to do a little bit of more smaller polish, and then we're going to start moving our volumetric cubical margin squares slowly to the GPU, probably step by step. Although yeah, it's probably not. I mean, getting the algorithm there is probably fast, but then let's see how fast we can get something to render. And yeah, another thing that I kind of didn't figure out yet, which I have to think about, is how I would want the data to be represented, like how we sync the data to the GPU and how we get it back, like in what format basically, because we need it for the physics later. So we definitely need some sort of sync back of the mesh. But that's not right now the biggest concern, I would say. Yeah, the first thing I want to do is create this game time thing. Basically a wrapper around yeah, the game time, more or less a struct that should get basically compiled away because it's just a zero overhead wrapper is the idea. Do we want to have delta time or... I mean, I guess we can have both, right? Is it like this? Okay, how is it again? Go with 64. Yeah, no, it is like that. Okay. And I mean, we probably want some plus operators and stuff like that. Okay, maybe not const, right? I mean, maybe we do a multiply. Although multiply we don't really want, probably. Or don't... Wait, maybe that is like that. Okay. So that should do it, I think. Do we maybe want to have this marked as explicit? Nah, maybe not. Okay, because then what we can do is mark that as game time. I think we put that into Onyx. What age? Somewhere here. And then we can have in ECS system basically one Do we want the delta time? Probably. I do think that makes the most sense. Now let's see, where do we have that? It's not in many places, I think. So the asset system, don't think it has an update. God damn it. That one probably... Let's actually search for that, because that makes the most sense. So for now, they all have the delta time in there. We will probably remove that if we don't need it, right? Or get milliseconds? Maybe get milliseconds, right? All right. So we have that. And volume system is fine. Now we have game core, and here what we need to do is, I mean, maybe, or we actually, maybe we built the entity. Okay, what is it called? ECS execution context, right? That one. Okay. Now we have here const ECS context. And that's that. And we can get rid of this. I mean, that can be the made const, right? So that should work. Oh, well, there's one, the camera system. Which one is it? This one? No, the other one. Oh, god damn it. Here? Yeah. Yes. Why do we cast it to a float though? Whatever. Ah, the get is a const. let's make it R constant, if that's what we want. I think it doesn't really matter. Okay, where there's one. Which one is that? Is it because... yeah. Alright. So that should work again. And still work perfect. And we have our terrain here as well. Okay. Ah, true. There was one thing. The light stuff was not working correctly. That was on my to-do list as well. But damn it. But I think I will put that later. So there's one last thing I want to do before moving to the terrain again, which is the entity registry currently. Don't really like how that's handled. So I'm thinking that we probably do something similar to the version that the node graph uses. So we have a node factory, right? Node graph factory. And here we have the registered nodes which return a new instance, and we basically will have the same thing. So we have this one, and we have an in-place function that returns. Oh, well, we can't. I think I remember. I mean, actually, it can work, right? Can be a void. Can it be a void? Hold on, maybe that is actually nicer. Oh, hold on, actually. Yeah, no, it actually can be a void. Actually, as components factory. Yeah, let's do that. And then we basically have this version where we do that one. Wait, hold on, actually. Yeah, we want an entity ID here. And we get an entity registry and an ID. Right, and then we do a registry add component of T with entity. We can even do we can't. Where can we? No, in this case we can't. And that's fine, I think. Is it worth it actually to do that, what I'm doing here? Because the benefit of that end thing is that kind of works out of the box. With the properties. Oh, okay. I see. Maybe that's not worth it actually, what I'm trying to do here. I don't know. Not quite sure why I wanted to have that anymore. I think it was mostly that I didn't like that we have like 2 IDs. But I think it doesn't really matter for now. Oh no, I know why I wanted it. because of the factory stuff that I could enable it to do. Maybe we leave that out for now. I'm not sure. Maybe that's just not worth it right now. What is that? Okay. Oh well. Let's look at source tree then and see if we can submit or not. There is a bunch of changes, holy moly. And we probably break Linux with it again, if I would have to guess. So I mean, that one is definitely garbage. We can revert that. Don't need to submit that one. So those ones we definitely want. That one we want as well. Game core set scene. Ah, yeah, I think that was fine. Because I think I was mostly that we had an issue exactly with when we set our time thing, our scene. Alright, so then that one, yeah, why not? Let's just clean up. Lighting system. I mean, probably we submit that now. Even though it's not fully functional, but okay. What is that for? Probably I submitted even though it's ugly as her. That one is fine. That one is good as well. volume system. Yeah, probably. I mean, I could submit all of that, but I'm thinking maybe that's not the best. Let's double check that then. Can submit that later. That one we probably won't. We can actually not submit that. So what's this? Yeah, we want to stage that. We want to stage those, and I think yeah, the lighting system we stage as well. That one we can leave out. And then the volume component. I think for now do a dual margin cubes here. Probably. Let's see how that actually looks, if that even works. Because then we don't need to submit the cubic margin squares, which probably I don't want to submit. Okay, I mean, not quite, but kinda. Probably it's because the position in the volume loaded is wrong. Probably the position here would need to be again the one with the transform. I mean, probably we can do that actually, right? Can't we do volume component? Junk. Get position. Yeah. I mean, that kinda does it, even though it's yeah, not nice, but that's because the things are missing the skirts. which is fine for now. So we can do that. I mean, I guess what we can do is push those. Marching, oh, where this one, right? That one, probably that one. Then the simplex noise we do separately. So yeah, let's push that. Edit new. Alright, so I start, and then what else did we do? Fixed. Or we could actually push that separately, maybe we do that. Sampler on stage selected. I mean, probably that's it. And then this one, stage, commit, fixed. There's a couple of other things that I want to probably push, but for that one I need to add a different repository to get them over, and then we can move on to the volumetric stuff again. And it's here, build dependencies, Onyx source. And I will basically re-implement that here. So we have asset system, and then here in the create, exactly. This one is wrong, and it should be T-type ID. Is the create functor. Then we have our new asset here. And then in get available assets, this one, just where this instead of the other thing. Then we have in material component, probably in the editor one, this one, yeah, here exactly. This is as well graphics, material shader graph, type ID, get ID. Then scene editor. We should not have that here. That shouldn't have been submitted to begin with. Oh yeah, and then entity registry down here, that is just component ID. Right, because I think that is card. With the storage ID, right? Yeah, exactly. Basically that. That is not what we need right now. That's why not. And then we have render graph task. Fine, or that is already correct here. And here we have the same thing. Okay, I think that's it. That should fix a couple of other things. So let's submit those. So this is basically stage. Fixed issues with wrong type ID for create and get available assets. And then we have removed fixed wrong create component. Okay, I think we can push that. And probably it doesn't work. Okay, two-factor authentication, fun. Sorry, one sec. Okay. So... Oh, this is the two-factor, okay. Okay, maybe not. Okay, good. Oh, I need a handkerchief in a second. Did it beard? No, it didn't beard. Okay, I will be right back in 1 second, and then we look at Linux, and then we fix that, and then we go to the terrain. All right. Let's see. What is it that you didn't like here, Mr. Clang? Entity system needed. Did we not remove that? What? Probably. Isn't this... what? Did we not remove that? So entity system.h is removed. Oh, maybe that's the wrong... No, that looks fine. Entity private. So the system is definitely gone, but did we not maybe... No, that is gone, what? How come that is a thing? What? Is it the same thing? But where? What? What the hell is going on? Why would it say that there is a system somewhere? Did we not remove that? I mean... Oh, there is a system here. What? Say what? Oh, was it in the wrong branch, maybe? Okay, it was in the wrong branch. Then the question is... does that somehow take the thing out of the wrong branch? Which would be kinda weird, right? Based on what do we cache this? Hmm. That's weird. That is fascinating. That doesn't really make a lot of sense, that error. I will probably look at that later. I don't think that's an issue. Wait, why is that not committed? Alright, well, I guess we just push those two. And let's see if that magically fixes it, but probably it doesn't. Alright. Let's go and work on probably the probably now the terrain again. Or I tried to look at the issue with the lighting, which is as well a big one. It's like both are valid options to look at. Maybe the rendering of the light makes more sense to look at first. I wonder, do I have still the source of the reference for the light? Probably somewhere. It's probably that. Sorry, wrong screen. It's probably that one. It's probably one of that. It's probably one of those. Mm-hmm. Yeah, that is probably the correct code here. I mean, that looks very much the same. I'm wondering what is this one, right? That's probably some sort of optimization, yeah. Which I think we will leave out for now. Because I don't think that that's worth it. No, let's actually move with the terrain for now. I'm not in, like... Don't feel like fixing the light for now, even though it's somewhat important, but... Is that... No, that still fails, and probably still fails with the same weird error. That's bizarre. How about, what if I delete the caches? And then rerun? Because I mean, that should do the trick, right? I mean, it's so bizarre that that would fail. Two commits behind. Ah, that's the build stuff. Ah, that is easy to add. Oh, it's fine, I guess. So now we are not behind, right? Yeah, good. Let's see if that makes it better now. So for the terrain, how do I want to approach that? Not so sure yet. I think there is somewhere. Is that the... Oh yeah, that is the compute shader thing. Okay, let's see if that builds now. I mean, there's definitely different errors now, so that's good. Okay, that's pretty good. Okay, cool. I think that makes sense. Okay, good. Let's do one thing at a time. So, what is it? No discard. Is it the order or what? Is it that it doesn't like the order that I put it in? Find our references. Is that it? I mean, it's all in hash, right? Yeah. And it's all about that no discard thing. Alright. Moved, no. Discard. Alright. Alright, let's start with while that is compiling again. Let's start with some action on the yeah, side of the shaders. So probably the shader will be in Onyx itself, because we will make that a core thing of the engine, right? So here data shaders, and it will be a compute one. And then we have volume, and then we have here probably a CSG thing for now. And then we have cubical marching squares. Header. And then we have probably a generate. Something like that. And we leave it at those three for now, but then we will add the octree again. I am pretty sure. Actually no, let's leave that here. Open those three. Okay. So let's see. The easiest one is, let's go to our CSG thing. And we basically have as well a sphere. Okay, so we have the vert position minus the sphere center. And then, yeah, we basically normalize that. Well, we get the length and then we normalize it, yeah. Our gradient is gradient divided by, well, no, not divided by, times 1.0 divided by the length plus 0.001. Epsilon. And then we return vec 4, where we have our gradient, and then have our sphere radius minus the length. And that should give us a sphere function. And then we add a couple of things here. Actually, let's maybe we add a marching squares thing here, where we basically put in cubic marching squares. No, it's not that. Is it here? No, not quite. This one. So basically we take all of that. Does it really support static? GLSR static. I mean, I think the static is not needed here. And then we have here, don't think we have that, so we probably just do a uint here. Unless GLSL types, that one I'm not quite sure, right, if we have smaller types. I think we don't, right, so it's just a uint, it's fine, I think. Could as well do, well, it was signed, so let's do it signed as well because we have the -1 here. Let's actually update the stream title. So we have that. Let me quickly still have that open though. Okay. No, that's not what I wanted. This is what I wanted. Actually, that would be a vec4, right? Well, where is the GLSL types again? That would be an IVEC4. Right, and then we can get rid of that because we just have those as the vectors. And then this is as well an IVEC4. And then this would be an IVEC2. That won't be an IVEC2 as well. And well, that's const and not const expr, right? Because there is no such thing as a const expr here. IVEC2. IVEC4. And I don't think we have that in my current version anymore. That's not needed. But we could have it. It could be an IVEC2, right? And then we just get rid of that. And then this is like that. Okay, and then this is basically my beautiful yeah, basically the header where we define what kind of thing it is. Alright, so that should be the lookup table. And I think we need one more lookup table probably, which is from our volume chunk loader. Is it that one? Ah, volume chunk load request, right? Yeah, here. So basically, it's this, which we don't really have currently. So that would be IVEC 4 again of 6 things, and then that would be our faces. What? 0, 1, 2, 3, 4? Did I copy 1 too little? Probably, it looks like it, right? Yeah. Five. Ah, god damn it. Okay. Alright, so that's that, and let's get rid of that and bring over the comment here as well. Which I'm not sure. I think this is the correct one, right? Or is it? No, probably not. I think I adjusted that to be... So probably that one. I'm not sure anymore which one is the correct one. But we leave with that. I mean, we can look at that 6420, right? 6420. Six, 4, 2, 0, yeah. So it's like this, yeah. Okay. Good. So I think all of those tables should be correct. And then this is 3021 is the ambiguous case here. And then 1302. And then this is 3120, I guess. And 1302. And then this is this. As the ambiguous one. Famous last words, but should probably be correct. We could double check that, right? So either it's thank you, no thank you. 3. Hold on, what? Six and 9. Okay, well, actually either it's edge, because those are the edges, right? So it's edge 3 to 1, like this. And then edge 2 to 0. Yeah, which is this exactly. Ah, that's how it works. Okay, yeah. Or it's 3 to 3, 0 to 3, like this. And 1 to 2. So this. 0 to 3 and 1 to 2, right? Exactly. And then the other case would be 3 to 0. Whereas before it was 3 to 1. Ah, yeah, 3 to 0. And then 2 to 1. Yeah, makes kind of sense. I think that should work. We'll probably find out once we have an edge case. All right. All right. So we have those tables done. And then let's add this helper here, which is basically not this one, right? But it's probably this one. Yeah. I will put it on a separate screen and then we'll try to add the shader here. So it's basically we give it out a uint. What is that uint actually? Ah, it's the case. Yeah, it's maybe helpful, right? Then we have a uint 8 base index. And then we have, I think it supports out parameters. Well, actually we have in parameter. Does GLSL support that? Oh, okay. So I guess we don't really care about that, never mind. And then we have vec 3 of the 4 corners basically. And we have another vec 3 of the normals. Or like Hermat data, sorry. It's the vec 4. As well with the vec 4. And then we have an out of line segments basically. $24 of each. So for that we need a struct, of course, here. Which defines a line segment. I do think we want to have it like that, right? I'm not sure. But I think I want to have it like that. Where we basically have a vec3 from vec3 2. And I think we want to have... yeah, it's basically a vertex, right? So we have vec3 from normal and vec3 to normal. And we have as well a uint from edge index, uint to edge index. That might not be the smartest thing to do, but for now we will do it like that. We will see how the performance is. There might be potential to optimize it. Alright. So then the thing is kinda straightforward. So we take a uint 8, or sorry, a uint. X index is our phase chords and our phase index at X. And then we have our uint Y index, which is that at Y. And here we include compute volume marching squares.h. And then we have u vec2, well, yeah, vec2 corner 0 2D is basically our corners at 0, and then at the X index. Does that work? Can I like, I hope I can do that. And corners at 0, and then Y index. Then 1, 2, 3. 1, 2, 3. 1, 2, 3. All right. And then, oh yeah, we do a float. min is not quite sure what I can initialize that to in GLSR, but that should be good enough for now. And then we basically check our 4 indices, well, our 4 indices basically. Although, do we need that for now? I mean, probably. Wait, is it a... Oh, well, okay. Well, actually we could do that, right? Min. Then vec to max. And then can't I... Does that work in GLSR? Can I do but how does that work with with a vector? Okay, so maybe that works. So min is... Well, actually min is then min of corner 0 and the min of corner 1 and the min of corner 2 and corner 3, right? That should be that. And then vec max is just that. That should do the trick, I think. And then we have a u int marching squares case is basically our Hermite data at 0, and then of course the w is less than the ISO lever, which we need to define as well. And then if that is the case, then we do 1, otherwise we do 0, and then we OR that together. Two, 3. And this is 4, this is 8. And then if our marching squares case is 0 or it's 15, then we are basically completely filled, completely empty. We don't need to do anything here anymore. And we can just return our marching squares case. And then we leave out the ambiguous case for now. Which is basically if our MS table at our merging squares case at Z is greater than 0, like this, then we have the ambiguous case. As we continue. And then here we have a U and again, which is the edge 0, A. We have MS table at the merging squares case at X. And we go well, actually, let's call it from to, right? That makes it a little bit easier to read. And then we have U and cube edge 0 from and then we get our 0 crossing basically. Exactly, so then we do edge 0 from corners are my data and edge, well, 0 crossing position, 0 crossing normal. Edge 0 from vertex, well, from position. Then we do the same with the 2 position and 2 normal. And then if basically resolve face sharp features, or face sharp feature, god damn it, face index edge, that's the vertex thing, so from position and edge 0 from normal and edge 2 position, edge 2 normal. And then we get out some vec3 intersection position and vec3 intersection normal. Actually, maybe that supports it, right? That would be nice. Let's create this spool resolve face sharp feature, where we take a uint face index and vec3 from position, vec3 from normal, vec3 to position, vec3 to normal, and then out vec3 intersection. For now we return false, but handle here. That's the easy case, right? In this case, we just have our line segments. And we basically... Do we ever place more than one? No, right? Oh, we might actually, in the ambiguous one, we might place more than one. So I think we basically... So here we add at maximum 1. And if we are ambiguous, we might add 2. So maybe we do that. I'm not sure. I mean, maybe we can do that and have a int. Not sure actually what the best would be. Maybe we just give it a segment index as well. Something like that, right? Then we have basically here is a new segment where we do a line segment. From is... God damn it. Oh no, stop it. Where did I move everything? Basically add 0 from position. And we have the from edge index. and that is this one. And we have from, well, 2 edge index. And then we push that in there. Right. Might work, might not work. And then here return marching squares case. Okay. So that's that part. And then the only other thing is basically we need to have probably have how do I run that? I mean, yeah, probably it is like that. Basically avoid what is it called in the other one? But I mean, it doesn't really matter. No, where was it? Here. I mean, it's basically generate mesh, right? Yeah, probably. And we get a U in 3, which is our ID basically. Maybe. Or not necessarily. Let's see, I'm not sure about that part yet, but basically we run over our 6 faces. And yeah. Then we build our face thing, which is basically a vec. Or we can have that here, right? A vec 3 of corners of 4 things, and then we have a vec 3 of vec 4 of hermite data of 4. basically. And then per phase we fill that, basically like that. So basically on the corners, and then this and phase index, and that is X, Y, Z, W. And then don't do that for now. We have a line segment. On 24. And then we have a U and next line segment index. Now we give phase corners for my data, next line segment, and outline segment, yeah. And then this is just generate lines, right? Raise segments. Why did we copy that? Oh, well, whatever, I don't know. I mean, probably now we want to have a pool of raised segment 24, and it's basically 24 times initialized to 0, or like force. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if we take those and copy them, then we should be at 24. Or do we need that? Oh, not necessarily, right? Let me double check my algorithm again. So what do we do here? No, actually we do that. Then we do for each uint segment index, and we do 0, we go from segment here to segment 24, and then we do a plus plus segment index if traced segment at segment index. Then we continue, otherwise we set it to true here. Or do we? Yeah, we do actually. Yeah. Probably. Probably we do. And then basically we have components, which I'm not sure how to define them yet. I don't know. Worst case, I guess we can have up to 32 or something like that. Vec 3. Let's actually do a vertex struct vertex for now. That will help us a little bit. Vec 3 position, Vec 3 normal. And then the component is just let's have here and then components, and let's for now do 12. I don't know, it's really arbitrary how many I have here. Probably need to evaluate how many I can actually have realistically, because it's a solvable thing. But let's do 12, because if every component, like one phase can go return 2 components, we have 6 phases, so I think 12 makes sense, right? At worst case we have like 12 components. But even that is probably not correct, because they have to like link to each other, most likely, but whatever. So basically we have always a vert. Like, does that make sense? No, that doesn't actually make sense. So it's actually like that, right? And then we have multiple of those. How can I do that? Maybe we do a component for now, just to keep it a little bit easier, right? Component. And then this has a list of vertex, which let's now do 12 here, and then we have components. And we have 12 components as well. And component index is 0. Then at the end here we do component index plus plus. And then here we do component. And then we fill our component with the line segment data. So add component index. Let's actually have... Probably have to have a vertex count here. So vertex count is 1. And we have a U and edge index. And we basically go through... Well, that one stays, right? That one stays like that. And then we go through our 4. Or we can do vertex count 0 actually. And then for our U and wait. Yeah, I have point or vertex index or line point index. Oh wait, that is right? So actually then okay. So here we do line points count. And then here we do line points count is 2. Then segment add line points at 1. From vertex. That is from. That will take quite some time until we have something here probably visible. All right. Then we can probably optimize it. So plus plus line point index. And then basically what we do is we have the component at our component index, and that one has vertices, and at basically our vertex index, which we then increment, we set our outline segment at line point index. Then we mark this as traced. And that's that. And then bool has added. And then while has added. Has added is false. And then we basically do the same thing again. And we do trace segment index. So if our trace segment index is the same as our segment index, we can continue. If our well, actually then it doesn't really matter, right? If we already traced, we continue. The edge index is our outline segments at segment index to edge index. And then if our outline segments at the traced segment index from edge index is our edge index, then we do something as if our to edge index is the same, right? Then we do as well stuff. And we basically do the same thing here, which is we have line point index. This one is our trace segment index. And we add our line points. And in this case, we add them from behind. Honest, whatever. Not questioning it. do an int here, otherwise we have a problem, right? And we add that to that list. And then we say has added is true. Both of them. And then we say edge index is here we do the to index. Here we do the from index. And then we mark in both cases the traced segment as traced. And clear it from the list. And that is basically the tracing, I think. Oh well, and then once we have added that, if our component had 0 is the same as our components at vertex index -1. Position. Then we basically just remove that one, like either one of them, doesn't really matter, right? But I guess the easier one would be to remove the end. Oh god. So that's what we want. And then regardless of that, we set here vertex count to vertex index. Okay, cool. That's the components, right? And then here we can build the mesh. What is with my audio? Not quite sure. Oh, it's my headset that's not really feeling it, I guess. Yeah, something is weird with my headset. Alright, so then here we build the mesh. And the mesh building... I'm not quite sure yet how to do that. And especially we wouldn't want to add multiple copies of the same vertex, which I'm not sure how to do that on the GPU, to be honest. that one I'm not quite sure how we do that. But maybe we don't care about that. Triangles append. What is triangles? Oh, okay. Oh god, my headset is killing me. I mean, probably something like that I would want as well. Ah, sorry, wrong screen again. Man, I'm always doing that. I mean, that's a sample application that probably is not the same level of the cubical margin squares than I have. Because I think mine is a little bit more advanced than that. Oh, okay, I see. Oh, that's ugly, holy moly. But I think I will call it a day for today. I'm a little bit tired today. I think the mesh we will check on another day. But in theory that should already be half of the stuff done. I mean, we don't have the full case handling, but for a test case with like a sphere, this should be enough because we don't end up here in a sphere and we don't end up here in a sphere, so everything should be fine. And we should be able to triangulate a sphere with this. So we just need to generate the mesh, which is still big enough of a problem, but doable. And yeah, then that should be that. And we can add that thing to the meshes. The weird thing is, how is that handled? Because doesn't that... Append structured buffer, what is that? Is that thread safe? Is that really thread safe or what? Okay. I mean, I guess that's how it works. We probably need some atomic stuff then, in our case. Which is fine, right? Okay, I will look at that on the side. But yeah, we will be back on Tuesday with another stream, and then we will add the mesh and hopefully be able to test that volumetric stuff. In the meantime, probably tomorrow I will fix again Clang, because yay, and probably push an update to the repository with a new bug fix version, because basically all the stuff I submitted today was smaller bug fixes here and there for the string IDs that we added, and yeah, kind of broke a little bit. So yeah, that's that. Thank you very much for joining though today. I hope you have a great rest of your Sunday evening. And yeah, we will see each other again on Tuesday. Stay safe until then and have a great start into the week.